Okay, so we're continuing with our with the topics of today's Orca Hub weekly session. We're going to talk about the well intervention using the AlanaPy script and the Open Server. As you can see, I've previously created a notebook that has all the elements in order to make the appropriate connections to the server. As you can see, I've provided the AlanaPy, the updated, I updated with from the PyPy repo. I've instantiated, in this case, a class from the AlanaPy.data source class from the script. I'm only going to use this data source class for this exercise. I've provided with the Alana token and made the appropriate connection for the server, in this case the open server, and connection established successfully. Okay, so continuing with this exercise, well, we're going to of course we're going to get the both wells. We're going to make some exercises and some visualizations of different well interventions that we have in the database from the both wells. We've done this several times using the get fields wells dict. We indicate both the field, and we're going to get a list of wells as such. There you go. And we're going to, in this case, what happens if I call the instance that we've created, and if we go and type get, well, like you can see here, you'll get this get well intervention. Let's see what does this function does, and it says the function that fetch the well intervention data of a given well name. In this case, one of the arguments, it's the well name. So we need to loop, and we need to provide this function with the well name. Okay, so I'm going to do, for example, I'm just going to call the first index of this list. Let's see what we get in response. As you can see, we have we get a list of dictionaries with in this case intervention type, purpose, activities, description, drain pressures, tested column, and downhole pump, blah 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 blah. We have initial date, a final date. We have as well a well FK, in this case for the flag, if you can say that, of the well name. But if we're talking in a database structure, that's why it's called a well foreign key. Okay, so and I would need first to get all of the well interventions, and in order to do that, I'm going to create a list called list response, which is, in this case, it's going to be empty. We're going to create a simple loop for well in list of wells, and we're going to I think that in previous sessions we've established that a list of dictionaries can be converted into data frames. So I'm going to append list response dot append. I'm going to append to this list the pandas, the data frame form of this response element, right? I'm going to change, in this case, this list wells, the index 0. I'm going to change it for the looping label, in this case, well. Let's run it to see what we are going to get. And there you go. It's running the kernel, successfully run the kernel, the 7th run. And if we call it, we visualize this list of responses. You can see a lot of data frames here. Okay, so I'm going to, instead of doing this, I'm going to, if I call, there's a function of pandas called concat, which if I provide a list of data frames, what pandas is going to do, it's going to concatenate them, and you can see the final response here, the final result. Okay, so I'm going to store this as df concat equals this. There you go. And there's something here that we are going to solve. I think that you guys might be aware of that. I'm going to, first of all, change the IDs, the WellFKs, for the appropriate well names of the wells. I'm going to do that by just running a couple of lines. We've covered this in previous sessions, so I'm not going to go into detail of what this does, but I think that you guys can be quite aware of what we're doing if you've been following us in previous meetings. I'm going to, in this case, create a new column on the concat data frame called well name, and I'm going to provide a replacement of those WellF keys or well foreign keys. I'm going to replace them with this dictionary that I previously created in these 2 lines, in these 3 lines of code. Okay, I'm going to run it and then print df concat using the head function, and we have the appropriate well name for each WellFK. Okay, so that's been done. I think that we're going to, in this case, I'm going to create, I have created in previously, I've created, in this case, I've created a function called pyplot variables, which I pass a dictionary of configurations, and it will create a subplot. In this case, 1 row for 2 columns with this fixed size, and it's going to plot, in this case, pyplot with the counts, and it's going to be create another. In this case, it's going to create a Seaborn count plot in the other axis. Okay, in the second column. Okay, so I'm going to pass on the dictionary of configurations. In this case, I'm going to the dict config is conform, or it's formed by a data frame and a column. In this case, I'm going to pass on the df concat and the intervention type. Okay, if I run it, there you go. It's stored this function. I'm going to execute this function, and I'm going to pass on the dict config. I'm going to run it, and as you can see here, we have the pyplot of the intervention type of all the data frame that I've given to the function. In this case, in all the database stored in the open server of all the wells, we have a 92% of workovers. Okay, we have a 2% of exploratory evaluation. Let's remember that this intervention type, but I think that we didn't saw the columns. Yes, we didn't analyze the columns. Let's go and review the columns of this df concat. Okay, we have an intervention type. We have an intervention type workover. We have a purpose, in this case cleaning for this ID or for this well. We have the activities. We have a description, We have an initial date, a final date, and the column referring to the well name. Okay, so if we made a simple visualization using a pie plot and a count plot, we see that in all the data frame, we have a 2% of exploratory evaluation in the intervention type column, and we have a 6% of completion. But this doesn't give us a lot of insight. What about the counts? Well, talking about numbers, specific numbers, workovers, we have plus 40 elements in this data frame. We have close to 2 or 3 completion elements or activities in this data frame, and it looks like we have a single element in exploratory evaluation intervention type for this database. Okay, so what about what if I want a bit more detailed information about what is inside those columns? In this case, I'm going to paste a simple loop using Python and some functions from pandas. In this case, you know that pandas has the columns, the property columns that calls all the columns of the data frame and as well a function called unique that will give you all the values, all the unique values on any given column of a data frame. So in this case, I'm going to I'm looping in columns of the data frame, and I'm creating a list unique or a list of unique values of that column. And if this list is bigger than 5, it has more than 5 elements in it, it's going to print only 2 elements, and it's going to give you a count of the total unique values of this column. And if not, if it's less than 5, well, it's going to print all the list. Why I put this threshold in 5? Well, because it's visualization. It's going to be a visualization issue, so you're going to be able to see that if I run it. As you can see, for the ID, we have either a 1 or a 2, but we have 48. In fact, we have 48 unique values. So this list goes from 1 to 49, looks like. The intervention type, we have 3 unique values. So in this case, it's workover completion or exploratory evaluation. The purpose, we have 5 unique values. In this case, cleaning, well completion, exploratory evaluation, change of lifting method, workover evaluation. For activities, we have 8. So this list extends to 8 elements. But the first 2 are cleaning / conventional oil or gas. We have completion and so on and so forth. The description, as you can see, we have several unique values. We have different description for different measurements or different rows in the database. And we have as well different initial dates. And in this case, we have 47 final dates. So one of these activities didn't ended in maybe in a different day. It ended in the same day, or there's a missing value there that the operator didn't upload, or maybe we kind of it's not like we forgot to add it. The database that we got doesn't have that final date. The well names, we have in this case the 7 well names regarding the 7 wells. Okay, so okay, excellent. This I'm going to, in this case, just for the sake of kind of visualizing the data types, and you're going to see why. As you can see here, we have several objects. We have integers, but as you can see, initial dates and final date are object types. This doesn't help us in the process that we're going to do. So in this case, we're going to change those data types into date time data types. In this case, I'm just going to use the toDateTime function of pandas. I'm going to pass on the initial date column and just replace that column as well as the final date. If I run it and I run this again, you're going to be able to see that, okay, now we are talking that initial date and final date are datetime 64 bits data types. Excellent. Why did I do that? Why did I do this? Well, because there's a function of any data frame that it's called group by. And this group by has, in this case, another function. You can pass the argument. In fact, let's review that. Just a simple df concat. Let's call the df concat. Let's review the function with the docstring. As you can see, the group by using a mapper or by a series of columns. It's an operation involves some combination of splitting the objects, applying a function, and combining the results. You can see that the parameters are this, label, as index, and so on and so forth. But I'm going to use a grouper, which is a much more, it's another function of pandas, but it gives you a little more of, in this case, datetime manageability, if you can say that. I'm going to pass on the key. It's going to be the initial date, and the frequency, it's going to be a monthly frequency. And I want for this function to count the intervention types. Okay, I'm going to call it as such, and we are going to get this data frame, which in the index column, we have the frequency, the monthly frequency from the initial date, and we have the intervention type count in each date. For example, in 2014, February 28th, we have 0 events. In January of that same year, 2014, we have 2 events. In 2013, on November, we had 1 event, and so on until 2020 of November, the 13th of November, we have 1 single event. Okay, so what happens if I want this to be sorted in an descending in a descending way. In this case, we are going to get the intervention type from the larger to the smaller or thinner. We're going to use the df. I'm going to call this new data frame df group. It's going to be like this, and then I'm going to df group. I'm going to use the sort values function. Sort values. Oops, it replaced the row. And I'm going to say from which column the intervention type. That, and the ascending. I don't want it to be in an ascending form. I'm just going to pass a false, a Boolean value, and I want to print only the first 10 elements. And as you can see, 2019, December, we had the more frequent intervention type in the database that we have. We have 2014, 2 events on January, and so on and so forth, like this. Excellent, excellent, excellent. So this gives us an idea of how well intervention types happen in the in a timeline form. But what about if we want to visualize it in another form, in a more graphical form? I'm going to change I'm going to change the theme in this case for a white grid, just to visualization purpose. And in fact, I'm not going to change the palette. The palette, I'm going to leave it like the Seaborn dark grid palette. But I'm going to call the histplot function of Seaborn. I'm going to pass the df group in the data argument, and the x, I'm going to say that I want as the x-axis the index of this data frame, which goes for the initial date. The y is going to be the intervention type count. Okay, and in this case, I'm going to put an 80 bin, which it's going to only to it's going to cut the length of the histogram. And we're going to get a plot like this. And as you can see, we have in the x-axis the kind of the time series, right? And here we have the account of intervention types. We have in 2014, 2 events here, close to the end of year of 2015. We have several counts here. We have no counts here in the 0, but we have several in 1. As you can see, the only point in time where we had a 3 event intervention, it was on the 2019, the end of this year. We had several interventions in this date. And it was previously we had 2 events, and after that we have several another 2 events, which kind of gives you the idea of what is happening here in our wells. Of course, a much further analysis can be made, but as you can see, this is Python, and the mixing of the AlanaPy and Python, it's quite convenient to visualize in a visualization standpoint for further analysis. I'm going to for the next, I'm going to just import, as we've previously seen, the IPy widgets function, or the library, sorry. I'm going to select from the concat some columns. And in this case, I'm just going to, as you can see here, I'm going to paste a very simple loop. I'm creating from this loop from the well names. I'm creating a temporary data frame of each well name, and I'm grouping, in this case, for the purpose column, and I'm counting. I'm going to create, in this case, a bar plot with this fixed size. And I'm going to create kind of the x-ticks. I'm going to rotate them 45 degrees. I'm going to put a well intervention for, well, in this case, the looping element. And I'm just going to show it. I'm going to delete this. I'm going to, there you go, executed list well names, of course, because it was list wells. There you go, list wells. There you go. I'm going to run it, and we have the bar plot for each well. We have a well completion for the F14. We have a well completion for the F12. We have a cleaning intervention for the F11, but we have the interesting well is this F5 that has a change of lifting method. It looks like it's beyond 0, which is maybe a 1 element or 2 elements. We have cleaning close to 20. And we have a workover evaluation as well. We have several. In fact, it looks like we have 2 events here. So what happens if I don't want to visualize all of that? Well, I created here with this. That's why I imported the AlanaPy widgets. I'm going to import here. I'm going to create a function called df well intervention grouping that it's going to, in fact, this list well names, I mean, I previously created list wells, but I'm creating it again, just memory usage. We need to be have caution about memory usage, but for this, for the sake of these exercises, I just going to leave it like that. But what this does, it's as well, I'm creating a temporary temporary data frame of that well name. I'm grouping, and I'm creating, in this case, the same plot, but I'm going to use the interact function of Python, and I'm going to pass in the arguments the well intervention grouping. In this case, I'm going to create a drop down using the list of grouping, and the list grouping. This list grouping, it's empty. Looks like, yes. And the list well names, yes. This list grouping is missing. And why is missing? Because I forgot to put it there. But it matters not, because I know that the grouping either is going to be purpose or activities. I'm just going to purpose of or activities. There you go. And I'm going to change this for purpose of activities. And there you go. I'm going to run it. And as you can see, we have, I want to group by activities, and I want to visualize the F5. And as you can see, we have cleaning, we have cleaning of injectors, we have conversion, we have flow rate measurements, flow meter, we have wireline flow control valve operation, we have wireline operation with logging valve as well. And if we change for purpose, we have change of lifting method, cleaning, and workover evaluation using Python elements and Python tools for visualizing data and managing data. Okay, so this is quite interesting. We can keep digging information from this database. You guys can, if you install, then again, I ask you guys to download the AlanaPy script, install it on your PCs, and try to experiment with this open server. And let's open the discussion regarding the data that it's available for you there. Okay, so I think that this concludes for this well intervention workflow. Let's go back and let's check for the well pressure workflow. Okay,